everyone, welcome back to Let's Embark. So we are in fifth video of Unit 2, Concept Review plus 3-type problem solving. So it's exponential function, context and data modeling. Yes, we know how to model a function. We will check for the features, right? So especially we are going to practice and see how to model exponential function in different contexts. So let's go. We know this is very basic, but still I'm starting with that. Exponential function will look like a times bx, a very basic form. A is your initial value, b is a factor which decides either it's going to grow or decay, right? Now, applications in data modeling. Population growth, that is exponential application. P of t, like something it will look like this. P naught is initial population. And what is this E? E is called Euler number, like how we call pi, right? So it's an Euler number, it's something 2.71. And R is growth rate, like 10%, 2%, something like this, maybe decreasing or it's increasing. And T is time elapsed, right? So this is one. And radioactive decay is another application. A of T, so it depends on the time T, right? A naught, initial amount of whatever substance, and decay, radioactive decay, so of course it will reduce, right? So that K and times T. Compound interest, one of the important application in finance. A is principal times 1 plus R by N into N power T. So principal is initial. Anyways, this thing is going to represent initial. Here principal amount, R is annual rate interest. But it depends, like, are we getting compounded annually or like monthly? So that we divided by N, right? Monthly means you will divide by 12. Quarterly means you will divide by 3. Every 3 months, it will be compounded. So that thing, and T is in here. So these kind of manipulation will be done, depend on the context. Now, disease spread, epidemiology. I of T equal to initial amount of disease, like infected people, into e power kt. It's growing or it's getting decay. So that factor will be K, and over a time T. Carbon dating, based on the decay of carbon. So they will find the age of a tree, something like this, right? So that is also based on this. So whenever decay, you got a minus. Whenever it's an increase, we got a exponent as positive. Now, characteristics of exponential model, when b is greater than 1, and like r is greater than 0 in rate cases, right? Whenever we say rate, it's greater than 0, it is going to be a growth, doubling, tripling, something it's scaling up. Decay, when your b is between 0 and 1, but when we come to rate, it can be less than 0. So radioactive decay, all this. So that's it. Now, we are going to model a context, and we need some techniques to be learned here. So like from table, how can I make a model, exponential model? So that's the first question. Below is a table of values for an exponential function of the form. They give you, this is not just general form, a b power x plus k. And these are the table, I should make a form for this. So first you will look for initial. And what is the factor, either decay or its growth. And then k, this we will find it. So let me tell you one thing. It's not like simple as linear. So pay attention here. When x is 0, 0, 7, if you plug in, you will get 7 equal to a into b power 0 plus k. So I got something like this. 7 equal to a, b power 0 is 1, right? So a plus k. So we have this. Now, if you go like this, like for example, 1, 10, if you plug in, it won't be that easy solvable, like if it's a non-calculator paper. So a times b power 1, sorry, it's not 7, it's 10, plus k, and we got like 3 unknowns, correct? So it's quite complicated. So what you should do is to find b, we will use the basic exponent reasoning logic here. So let me take some space here. So how will you find that b means? First, you find the differences, and this x values should be equally gapped, like equally spaced. So 7 and 10, the difference is 3. 10 and 16, it's 6. 16 and 28, the difference is 12. 28 and 52, the difference is 24. Now, you will check, like this is forming an arithmetic, like a geometric sequence or not. If it's exponential, it will form a geometric. So 3 times, what is the ratio? 2, right? Like 6 by 3 is 2, 12 by 6 is 2, 24 by 2. So that's your B. That's it. So now your equation is actually f of x is a into b is 2, 2 power x plus k. Now you will have two unknowns. So that's easy. We know the techniques, right? Now you can plug in 1 and 10 or whichever you want to do. So 10 equal to a is a only, 2 x is 1 plus k. So 10 equal to 2a plus k. Already we have 7 is a plus k. So you can use substitution or you can just manipulate this. 10 equal to, I'm just writing a plus k. Okay, a plus k is 7. I can use it. 10 equal to a plus 7. A is 3. So we got a. So f of x is 3 into 2 power x plus k. What is k? Very simple. When a is 3, then your k is going to be 4. Right? So this is going to be 4. That's our final answer. Okay. So first I use the initial condition. I got a plus k equal to 7. But when you do the plug-in thing, you won't get b that easily. So we tried like we take the common differences, and that makes a geometric sequence. The geometric sequence common ratio is your b. Once you got b, you got another, like you can plug in some point to make a relation between a and k, and it's simultaneous equation solving here. Right? So next one, question number 2. The table present values of the function f for selected values of x. Find an exponential regression model to fit this data. Round a and b to 3 decimals, but store the original regression equation in your calculator. Use the model stored in your calculator to predict the value of f of 1. According to the model, when will f of x is 100? When will f of x is 1000? So we are going to use Desmos here. If you have, so you can pause the video and get your Desmos now. Right? Okay, so how to make a regression model? Very simple. You will just plug in the values, like feed the values in Desmos, the table values, and I will let you know. So let's go for Desmos. Okay, here we go. Desmos is here. So first go for table creation. So we have x and f of x. So I'm just referring the table. X is something -5, -3, then 0, then 2, and 4. Then y values are respectively 25, 40, 120, 300, and 710. That's it. So how can I make a regression model? Next, you take another tab like y1 is approximate symbol, not here, here. Approximately, the model they said is a times b power. Don't use x, y, use x1, y1. So this is a regression model. For this data set, this is exponential regression, and it shows your a and y value, correct? Sorry, a and b value. So this is an approximate fit for this data, correct? So we will store this, and maybe you can make a function out of this. It's easy for computing the values. F of x is, your a is this one, right? The regression parameter here is this times, this is your b, power x. This way you can do. See, they are exactly matching, correct? Or you can, oh yeah, this is easy. Okay, so let's have this, and here we go. Let me show the thing. Actually, the question is round to 3 decimals, but store the original. So let me round off and represent the answer here. Okay, so the A part answer is, it's directly from calculator. Okay, you should write something like this. F of x is equal to, I got my A as 126.19324. As per the instruction, I will go with 3 decimal places. 126.193 into b power x. So what is my b rounding to 3 decimal places? 1.5395. Actually, this is what you got. So when you round off, it will be just 1.5 whole power x. So now use the model stored in your calculator to predict the value of f of 1. And I'm going back to calculator now to solve the other 3 parts. So this is my equation I have stored. Now they want f of 1. Sorry, we just give 1. 194 point this. Then, okay, I hope you can see it. Yes. So this is the value. And let's switch to this. It's 194.33127. Something like this. And according to the model, when will f of x is 100 and f of x? So now f of x is 200, we need to find the respective x values. That's simple again. So you have to put f of x equal 100. So that will show your intersection part. Or you can do this. Just a second. Okay, here we go. So the intersection of graph and this, which is negative 0.53884. Right? And similarly, f of x is equal to 1,000 or 2,000, something we have asked. 1,000. Okay, actually it's 200. We need to check. So 200 and then f of x is 1,000. So here are our values. 1.0666 and 1,000 is 4.7943. Right? So let's go for 200 again to check whether it's correct. Yeah. So that's it. We got our values and we can present it in our thing. So very simple, mostly calculator based. And this is something I forgot. Just a moment. Okay, it is 4.7943. This is the thing. Now let's move on to the last but not the least one. Here. In the xy plane, the graphs of linear function and the exponential function, linear function L and exponential function E both passes through the points. The exponential function E is in log form of AB power x, and the function is given by f of x is E of x minus L of x. What is the minimum value? So, like points are given, I should construct exponential function here. Very simple. When it's 0, it's 3 means that is initial value. So your A is 3. Okay, so it's 3 into B power x. How will you find B then? It's basic manipulation. So 2 comma 12 you can use. 12 equal to 3 into B power 2. And 12 by 3 is 4 equal to B square. B is 2. That's it. Your E of x is 3 into 2 power x. Right, this is my exponential function. And L of x is linear function. You know how to find it. Mx plus b form. This is y-intercept. So your b is going to be 3. Mx plus 3. How will you find m? Yes, you've got 2 points. So you find the slope. 12 minus 3, 9. And it's going to be 9 by 12 minus 3 is 9. 9 by 2, x plus 3. That's it. So now, A function f of x is given by e of x minus L of x. We need to find the minimum. So 3 times 2 power x minus 9 by 2x minus 3. So you sketch it and find the minimum value using Desmos A. Okay, let me share it. Desmos time. Okay, I'm just moving all this. So your f of x is something like this. 3 times 2 power x minus 9 by 2x. No, 9 by 2x plus minus 3. So we got something like this. Let me see the minimum. This is the minimum we can see, right? And you can go for that point. It's not x value. Minimum value means it's always y. So negative 1.51. This is your answer. Okay, negative 1.5 big since we are checking the minimum. Right. Let me go back to the whiteboard. And we are finalizing the solution now. Like we are completing every problem. So this is the answer. Negative 1.51965 is the minimum value. That's simple. And yeah, so that's it. Yes, as usual, I have a bonus question to you. Here it is. A new medicine is introduced into the bloodstream. At time t equal to 0, the concentration of the drug in the blood is this much. And it decreases exponentially. And after 3 hours, the concentration drops. So these are not tablet values. So you just make the coordinates. And you have to make the exponential model form. Maybe you can use a structure given in second point. Use your model to predict the concentration after 6 hours. Maybe direct plug-in. How many hours it will take until the concentration reaches 10 milligram per liter? How does the base in your model represent in terms of drug behavior? Yes, so do practice. If you have any doubts or questions, you can drop them in comment section. And we are in the final part of the video. Yes, if you want to join student community, scan the QR code. And that's it. Keep learning, keep practicing. I will be meeting you next video. Stay curious.